Hi, gentlemen. Students asked me to help with question 5. Gosh, it's a wordy question, but that's what it's all about. Maybe reading it a couple of times so you get your head around. Of course, this is the famous Leaning Tower of Pisa. Um, Actually, I have been there, so I've seen it. And you actually, from one particular direction, it doesn't look like it leans at all. But anyway, that's another story. Okay, clearly what they want to find out is by what angle does it lean by. And so it goes on a bit about this side as being a certain distance. So that's certain height there. And this side has a certain height. And then they use those two heights. They want you to work out the average height. And then they say that the horizontal move shift is a certain distance. Well, clearly we're going to be able to use and create a right angle triangle. So what we need to do is go away and work out what the average height is for the center part, because that's what they want you to use, the average height. So the average height for part A, wow, how that's an easy one marker. Okay, that's all it'll be worth. Average height, it's just simply um, equal to 55.86. I'm not even going to use my calculator. And so we've got 6, 5, 2, 1, 112. Divide that by 2, you got 5, 6.28 meters. So that's its height, 56.28 meters. We can now draw the triangle. So remember, that's its height there. Um, the the center actually has moved across. Um, so in actual fact, no, this is its height. The average height of the tower above the ground. Ooh, so this is 56.28. But we know that the has shifted across. So the center is no longer in the center; is moved across, which is that there, a total of 3.9 meters. And so we asked determine a suitable diagram, and there's the height and displacement. That's all you need to do. And mark the angle of lean of the tower. What did it say? The top of the tower is placed. Okay, obviously that's the angle there. Theta is there. That's all they want. And now they want you to calculate the angle in degrees, so nearest degree and nearest minute. So obviously we're going to find that this is the hypotenuse opposite the right angle. As you can see, this is the theta, this is next to, that's adjacent, and we have the opposite. So we'd have tan theta equals O over A, and we have some people actually can jump straight away to theta because we want to get that. We need the inverse tan of that ratio, which is in this case 3.9 over 56.26. And we go to our calculator for that. Though, remember, you guys are in my class, so we've got the trig. So let's go trig. So the opposite side was 3.9, and the adjacent was 56.26. 6.26. Um, no way would you be expected to do this without the aid of a calculator. So we end up having our angle there calculated for, which is this one here, 3.9654, 3.9654. Um, and we can just simply go, scroll down, that's 3.965. Oops, let's have a look. 965 457 457. Press enter, and we degrees, you can see we have 3 degrees, 57 minutes, 55 seconds. Be careful at 55 seconds. You need to hover over it, or let's see if I scroll it. It might drag it across. Remember, there should be the minute. There's the seconds. So there's your seconds. So it's 55 seconds, which means it rounds off to 58 minutes. And of course, 58 minutes would round off to 4 degrees. So the answer is theta to the nearest degrees. Oh, let's just put the 3 degrees 50. Sorry, what was that again? 57, 55, 57, 55, 57 minutes, 55 seconds. So therefore, it is approximately 4 degrees to the nearest, or approximately 3 degrees, 58 minutes. Remember, the cutoff is the 30. If that was 49, it would still be round off 30 seconds, rounds off to the next minute. Hopefully that answers your question. So again, a couple of drawings this time, and yeah, it's just a very interesting, wordy question. Hope that helped.